Students, today we will introduce the classification of VLAN and the significance of this classification. In the previous lessons, we learned that switches operate at the data link layer, which is the second layer of the OSI model. All the ports of a switch are in the same broadcast domain, while each port has its own collision domain. To divide the ports within the same broadcast domain into separate broadcast domains, we use VLAN technology. Let's understand why it's necessary to segment broadcast domains. Firstly, in a flat network structure like a switch network, broadcast is essential. However, having a large broadcast domain can lead to issues such as bandwidth waste, decreased security, and difficult management. Therefore, we need to employ VLAN technology to partition the broadcast domains. What is VLAN? VLAN stands for Virtual Local Area Network. It allows devices from one or multiple local area networks to communicate as if they were connected to the same physical network, even though they are distributed across different LAN segments. As shown in the diagram, broadcast data sent by devices in VLAN 10 will not be transmitted to the VLAN 20 network. In other words, VLAN 10 and VLAN 20 are isolated in terms of broadcast traffic. Now, let's take a look at an example from real-life: a building with 3 floors. As shown in the diagram, there is one switch on each floor, and these 3 switches are interconnected. Assume that each floor has 3 departments: engineering, sales, and finance. By using VLAN segmentation technology, we can assign devices in each engineering department to VLAN 5, devices in each sales department to VLAN 6, and devices in each finance department to VLAN 7. Through VLAN trunking technology, devices within the same VLAN on different floors can communicate with each other. However, devices in different VLAN cannot communicate with each other. For instance, even though both sales and finance departments are on the second floor, they cannot communicate with each other as they are in different VLANs. There are several methods for VLAN segmentation, and we primarily use 4 methods. Port-based VLAN: this method involves dividing VLAN based on the ports of Ethernet switches. It is currently the most common method. MAC address-based VLANs are segmented based on the MAC addresses of each host's network interface card (ENIC). Network layer-based VLAN segmented based on each host's network layer address or protocol type, if supporting multiple protocols. IP multicast-based VLAN: in this method, each multicast group represents a VLAN. As mentioned earlier, port-based VLAN is currently the most commonly used method for VLAN segmentation. Let's take a look at the diagram below. From the diagram, we can see that ports 3, 5, 7, and 9 are assigned to VLAN 10, while ports 19, 21, 22, 23, and 24 are assigned to VLAN 20. This type of VLAN segmentation is a logical division, not a physical one. In other words, for ports 3, 5, 7, and 9, we make configuration changes in the switch software to change their logical states, rather than physically bundling the ports together using tools like screwdrivers or pliers. So, what is the significance of VLAN segmentation? There are several benefits. By isolating VLANs, unnecessary broadcast packets in the network can be controlled from spreading. It can enhance network bandwidth utilization, and it helps to reduce resource wastage. VLAN segmentation allows for the division of different user groups, enabling access restrictions between groups. Communication between different groups, in other words, different VLANs, is not possible. It enhances network security. Now, please complete the following assignments. The above is the content of our class today. Please take some time to think about how communication between different VLANs can be achieved through which technology.